So today's video is about histograms. So what is a histogram? A histogram is a graphical display of data. The data is grouped into ranges such as like 40 to 49 and then plotted as bars. A histogram is similar to a bar graph, but each bar represents a range of data instead of just one piece of data. So this first picture is an example of a histogram, and if you'll notice, this is showing the number of students, and then this is showing height in inches. So this is showing that between 50 to 54 inches, there's about 6 students between 50 to 54 inches, and then between 55 to 59, there's about 12 students, and then between 60 to 64 inches, there are 20 students, then between 65 to 69 inches, there are about 13 students, and then between 70 to 74 inches, there's about 4 students. So it's giving you a range. So in that range, there might be one student who, like in this first one, that's 50 to 54 inches. Not all of them are 50 inches, not all of them are 54. One person might be 54 inches, one person might be 52, another person might be 50, another person might be 51, but anyone whose height is between 50 and 54 inches is represented in this bar here, which is different from a bar graph. A bar graph is just showing you a bar for one piece of data. For example, this is showing the number of students that like each one of these sports. So the number of students who like soccer is 9, the number who like football is 4, who like basketball is 6, and who like some other sport is 3. So even though they look similar because of the bars, it's the ranges that makes a histogram different from a bar graph. So how do you create what are called intervals? And intervals are those ranges that we see in the bottom of our histogram. So intervals, one, have to be the same size. So you have to decide how big your intervals are going to be, and they have to be that same size throughout the graph. For example, you may decide that you want your intervals to be 10. So you may say that one interval is 1 through 10, another is 11 through 20, the next one is 21 through 30, and so on and so on. But it has to be the same size. Intervals have to go high enough to include your biggest number. For example, if 955 is my highest number, I have to be sure that I have an interval that goes to at least 955 or higher. Intervals cannot be so wide that all the values fit into one interval. So you don't want to make it so wide, like between 1 and 100, that fits, and then all of the values fit in that same interval. That wouldn't be a very interesting graph. So you want to make your intervals small enough that you can give, different stuff, that you can show different pieces of the information instead of one big bar. Intervals have to have a range greater than 0. For example, the range of an interval from 2 to 4 is 2. But an interval that goes from 4 to 4 has a range of 0 and can't be used in a histogram. So basically, you can't count by ones in an interval because they have to be an interval of something at least greater than 1. So let's look at an example of just how to create intervals, because that's a very important part of creating histograms, is actually deciding how big you want your intervals to be. So we have this set of data here. Our largest number is 96. The smallest number is 5. Our intervals must include these numbers. So there's a couple different ways that I can create my intervals. Option 1, we can count by 5. So I can have intervals that are a size of 5. So 1 through 5, then the next one is 6 through 10, then 11 through 15, 16 through 20, etc. And I may find that those intervals are kind of small and it makes my graph really long. So I may decide that maybe I'll count by 10s, and then that means I'll go from 1 to 10, then the next interval is 11 to 20, 21 to 30, etc. I may find that I may even want to go a little bit higher and decide that with the data that I have, it might be great to just count by 20s, where I go from 1 to 20 and 21 to 40 and 41 to 60 and etc. There is more than one answer for how you set up your intervals. You just have to be sure that it makes sense for the graph. You also have to make sure, again, that your intervals are the same size, and you also want to make sure that your intervals show the data fairly. Like you don't want, like I said again, you don't want the interval to be so big that all of the numbers fit into one interval. So for example, for this data set, because 96 is the biggest number and 5 is the smallest, I don't want an interval that goes from 1 to 100 because then all of the numbers land in that one interval. So now that we talked about intervals, now how do you actually create a histogram? Well, step one is you have to look at the values that you've been given and decide how big you will make each of your intervals. Step two, you want to create a frequency table so that you can find how many values fall into each interval. Step three, you want to label the X and Y axis on your graph. And then step four, you want to graph bars to represent how many values you have in each of your intervals. So let's actually practice doing a histogram. So the table below shows test scores for the last unit test in math class. So we're going to create a histogram to display the data. So in this table we see the test scores. So we're going to set up our frequency table first. And a frequency table gives you the intervals, and then it shows you the frequency, or how often or how many values fall in that interval. So our first interval will be from 93 to 100. Those are the students who got A's on the test. So if we look here, we see that there are 4 test scores that fall between 93 and 100, meaning 4 students got an A on the last test. The next interval is from 85 to 92. These are the students who got a B on the test. So if we look at our test data, we'll find that 2 students got a B. Our next interval is from 77 to 84, which is a C, and we want to see how many students got a C on the test. So we'll see that 3 students actually scored a C. Then the next interval we want to show is from 70 to 76, and these are the students who got a D on the test. And if we look up here, we see that there are 6 students who scored a D on the test. Then our next interval is going to be from 62 to 69. Now, of course, we know that anything below a 70 is considered an F, but remember, because it's a histogram, we still have to make the intervals the same size. So since all of the other intervals are 7, then we have to make all the rest of them to be the size of 7 too, even though that we know that all the rest of the intervals will be students who did fail the test. So from 60 to 69, there was 1 student who got a score between 60 and 69. Between 54 and 61, if we look at our list of data, we see that no student scored between a 54 and a 61. And then between a 46 and a 53, we see that 2 students scored between a 46 and a 53. Now, once we have created our frequency table, the next step is to label the X and the Y axis on our graph. So on our graph, we want to decide that the bottom is going to be our intervals, and that the side is going to be the number of students that are represented by each one of that are represented. So once we've created the intervals, and then once we label our y-axis the number of students, now what we want to do is we want to actually go in and we want to put our bars in. So between 46 and 53, we look on our table and we see that 2 students scored between a 46 and a 53, so that's our first bar. Now with the histogram, sometimes when people do histograms, they like for the bars to touch each other. Some histograms, they don't. It's really a personal choice. They don't have to, but most histograms, the bars actually touch each other. So then between 54 and 61, we know that there are no students who score between 54 and 61. Next, we see that 1 student scored between 62 and 69. Then we know 6 students scored between 70 and 76. So that's our next bar. Then between 77 and 84, 3 students scored between 77 and 84. Then 2 students scored between an 85 and a 92. And 4 students scored between 93 and 100. And if we're looking at analyzing the table, the one thing as a teacher that I can see is I can look at and see, well, the majority of my students passed the test. The majority of my students got an A, B, C, or D on the test. I can also start to look at comparing the number of students who failed to the number of students who passed. I can look at the number of students who got each one of the grades and compare them to each other. There's so much data that I can get simply from my histogram.